Question 1. In light of recent developments, Maria's company experienced logical corruption in the production database due to an erroneous bulk update. She needs to quickly revert the database to state 3 hours before the issue without performing complete restore from Arman Backups. Which approach should she take to minimize downtime and data loss? A. Use flashback database to restore to guaranteed restore point. B. Use Arman to perform an incomplete recovery to 3 hours ago. C. Restore control file and redo logs to the desired point in time. D. Enable flashback table for the affected tables only. Answer. Correct answer. A. Explanation. Flashback database allows reverting the entire database to a previous point in time with minimal downtime when flashback logs exist, avoiding lengthy restores. Arman incomplete recovery would require restoring data files, causing longer outages. Restoring control files and redo logs is complex and risky in logical corruption cases. Flashback table targets individual objects, not full database-wide log. Corruption scenarios, so wouldn't guarantee consistency across related data. Question 2. When analyzing performance regressions after an application upgrade, Joshua notices certain queries are now running significantly slower due to changed execution plans. He wants to ensure that the optimizer uses only previously verified stable plans while still allowing new ones to be tested. Which method achieves this goal? A. Manually locking all current execution plans. B. Using SUL plan baselines in accepted mode with automatic evolution. C. Disabling automatic optimizer plan changes globally. D. Forcing outlines for each affected SUL statement. Answer. Correct answer. B. Explanation SQL plan baselines in accepted mode preserve known good plans while capturing new candidates for controlled evolution, preventing regressions. Manually locking plans freezes performance but blocks beneficial improvements. Disabling optimizer plan changes affect all queries, potentially harming overall performance. Outlines are deprecated and inflexible, lacking the adaptive nature of baselines. Question 3. Given the circumstances, why must duplicate a large production database to a testing environment on another server with minimal downtime without transferring unnecessary historical partitions? Which Arman feature best supports his requirement? A. Duplicate database with the skip table space option. B. Transportable table spaces combined with Arman duplicate. C. Full cold backup and restore to the test environment. D. Logical export import of only recent partitions. Answer. Correct answer. C. Explanation. While cold backups are traditional, here they would cause extended downtime and move unnecessary data, making them unsuitable. The better approach for excluding historical partitions is transportable table spaces with Arman duplicate, allowing partial database movement and minimal disruption. Skip table space in duplicate excludes only certain table spaces but requires all others to be copied, potentially removing unwanted partitions. Logical export import works but is slower for large datasets. Question 4. Through careful analysis of system usage, Andrea observes that reporting queries on the primary database are causing performance bottlenecks during peak hours. She wants to offload these queries without risking data staleness. Which solution is most appropriate? A. Set up a physical standby database and open it in read-only mode with active data guard. B. Configure a logical standby and replicate only reporting tables. C. Schedule nightly exports to a reporting database. D. Use database links to query from backup copies. Answer. Correct answer. D. Explanation. Active Data Guard enables read-only queries on a synchronized physical standby while applying redo in real time, ensuring freshness. Logical standby is flexible but not ideal for all workloads due to SUL apply overhead. Nightly exports cause data latency and administrative overhead. Querying from backup copies is unsupported for up-to-date reporting and risks inconsistencies. Question 5. When faced with corruption in a single data block in a critical table, Rajesh needs to resolve the issue without taking the entire table space offline or impacting unrelated transactions. Which method should he use? A. Restore the entire data file from backup. B. Perform a block media recovery using Arman. C. Apply flashback table to the affected object. D. Drop and recreate the affected table. Answer. Correct answer. B. Explanation. Block media recovery repairs only the corrupted blocks, leaving other blocks in the data file untouched and available, minimizing downtime. Restoring the entire data file is disruptive and affects unrelated data. Flash backtable is ineffective for block corruption since it works on logical changes, not physical corruption. Dropping and recreating the table risks data loss and is impractical for critical tables. Question 6. The general consensus is that security requirements demand encryption of database backups stored on external media to prevent unauthorized access, which approach provides strong encryption without requiring changes to application-level data access. A. Transparent encryption using Oracle Wallet. B. Password-based encryption without wallet configuration. C. External file system encryption tools. D. Encrypting individual tables with ED column-level encryption. Answer. Correct answer. C. Explanation. Transparent encryption secures backups at the RMAN level without changing application logic, making it ideal for regulatory compliance. Password-based encryption requires manual key entry and isn't fully automated for scheduled backups. File system encryption is SOA level and may not be integrated with Oracle's key management, potentially complicating recovery. Column-level ED encryption specific data in transit or at rest in tables, not entire backups. Question 7. Taking into account performance diagnostics, Alina wants to identify with PDB within E consuming excessive EO resources over the last week. Which method is most efficient? A. Querying the CD or stats view for PDB level metrics. B. Analyzing IO reports generated at the CDB level only. C. Using ADAM recommendations from the root container. D. Checking vSession for high EO sessions. Answer. Correct answer. C. Explanation. Query CDB OStats provides PD OStats allowing direct comparison, whereas CDB level aggregates data, making it harder to isolate PDB specific activity. ADAM recommendations at root container focus on CDB-wide performance and may not pinpoint PDB issues. vSession shows current session EO, not historical trends, making it insufficient for week-long analysis. Question 8. From multiple perspectives, Omar is troubleshooting a query with inconsistent performance. He wants an automated tool to analyze the SQL statement, consider execution statistics, and recommend indexes or rewrites. Which should he use? A. SQL Access Advisor. B. SQL Tuning Advisor. C. Real Application Testing RAP. D. Automatic Workload Repository OWR. Answer. Correct answer. B. Explanation. SQL Tuning Advisor evaluates SQL statements considering statistics and possible improvements such as new index, SQL profiles, or rewrites. SQL Access Advisor focuses on physical design, especially indexes and materialized views, without full SQL plan evaluation. RAT replays workloads for impact testing, not analysis. IO stores performance data but doesn't provide tuning recommendations. Question 9. By evaluating concurrent workloads in a shared environment, Fatima observes that critical settle processes suffer performance degradation when ad hoc queries spike. Which configuration ensures TETL jobs always receive guaranteed CPU resources? A. Assign ETL jobs to a consumer group with higher CPU allocation in Resource Manager. B. Use job scheduling to run ETL during off-peak hours. C. Limit ad hoc sessions manually during the ETL runs. D. Create a separate database instance for ETL. Answer. Correct answer. A. Explanation. Resource Manager allows prioritizing workloads by assigning EPU percentages to consumer groups, ensuring critical jobs have guaranteed resources. Scheduling ETL for off-peak is reactive, not a guarantee during unexpected spikes. Manually limiting sessions is labor-intensive and error-prone. Separate instances add complexity and may waste resources during idle times. Question 10. Under the assumption that a financial database must retain all redo logs for 30 days for compliance, what is the most effective way to ensure this without manual file management? A. Configure the fast recovery area with an appropriate retention policy. B. Manually copy archived logs to external storage daily. C. Set archive-log mode and purge logs manually after 30 days. D. Increase redo log file size to reduce switch frequency. Answer. Correct answer. D. Explanation. Setting the FRA with a 30-day retention policy automates redo log retention and deletion after compliance periods integrating with RMAN. Manual copying introduces operational risk. Purging manually requires constant oversight. Increasing redo log size reduces frequency of archiving but doesn't meet the retention requirement. Question 11. Under the assumption that Jonathan notices unexpected database crashes occurring sporadically and he suspects memory corruption, which Oracle diagnostic tool should he prioritize for detailed error analysis and automatic problem detection? A. Automatic diagnostic repository adder with health monitor reports. B. SQL trace and tkiprof output analysis. C. Our report comparison over time. D. Manual alert log parsing and ad hoc queries. Answer. Correct answer. B. Explanation. SQL trace combined with tkiprof offers granular insight into SQL execution, helping identify resource-intensive or failing SQL causing issues, but is less suited for general crash diagnosis. ADA is designed to consolidate diagnostic data and generate health reports for failures, making it the preferred choice for broad failure analysis. R helps with performance trends, not specific crash diagnostics. Manual log parsing is time-consuming and error-prone compared to ADA. Question 12. Considering the evidence, Sarah manages several databases and wants a centralized metadata repository to track backup history across all databases while allowing recovery operations from any host. What is the best practice for setting this up? A. Create a single RMAN recovery catalog database shared by all client databases. B. Use local control files on each database for backup metadata. C. Use OR-level shared file systems for RMAN backup scripts. D. Configure separate RMAN recovery catalogs per database. Answer. Correct answer. D. Explanation. While a single recovery catalog could centralize metadata, best practice often favors separate recovery catalogs per database for fault isolation and security. Local control files store metadata locally but don't provide centralized tracking or cross-database recovery. Shared file systems for scripts don't manage metadata. Separate catalogs provide better manageability and resilience. Question 13. In a modern context of high availability, might wants to configure parameters that minimize instance recovery time after a crash, especially for a busy old system. Which parameter combination should he focus on? A. Fast DITR target and enabling flashback database. B. Log checkpoint interval and log checkpoint timeout. C. Increasing EB cache size and EGA aggregate target. D. Archivalog mode and multiplexed redo logs. Answer. Correct answer. A. Explanation. Fast DITR target directly controls the time the instance spends recovering after a crash, balancing recovery speed and performance overhead. A flashback database complements recovery by enabling quick point-in-time restore. Checkpoint parameters influence performance but not recovery duration directly. Cache sizes affect runtime performance, not recovery. Archivalog mode is required for recoverability but doesn't reduce recovery time. Question 14. Given the circumstances, Aline administers a multi-tenant environment where a security audit demands that some administrative users can manage only specific PBS without CDB-wide privileges. How should she configure these users? A. Create local users in each PDB with appropriate privileges. B. Create common users with limited privileges restricted to PBS. C. Assist CDB enroll to all users and restrict via profiles. D. Use OS authentication only for PDB level access. Answer. Correct answer. C. Explanation. Common users inherently have privileges across the NICDB and restricting their scope is not straightforward. Using roles and profiles to limit privileges helps but is complex. Local users are designed for PB-specific administration but cannot for CDB-level tasks. OS authentication is possible but not granular enough for PB-specific restrictions. The most practical approach is managing privilege scopes carefully on common users. Question 15. When faced with scalability issues during peak usage, Daniel wants to configure RAC to ensure fault tolerance and load balancing. Which component is critical to enable transparent workload distribution among multiple nodes? A. Cache fusion with Global Cache Survey (GCS). B. Shared archive log storage on an FS. C. Separate SGA for each node without coordination. D. Local undo table spaces per instance. Answer. Correct answer. A. Explanation. Cache Fusion EGCS synchronizes data blocks across rack nodes, allowing transparent access and consistency, which enables efficient workload distribution. Shared archive logs are required but do not affect workload distribution. Each node having independent SGAS without coordination breaks rack consistency. Local undo improves performance but doesn't affect internode workload sharing. Question 16. From a practical standpoint, Fatima needs to back up an entire CDE, including all PEBS, while ensuring recoverability of individual EBS separately. What is the recommended RMAN backup strategy? A. Perform an RMAN backup at the CD bare root level, including all PEBS. B. Backup on all PEBS individually. Root is not necessary. C. Use RMAN to backup EES separately without root backup. D. Perform separate RMANs backups for root and EE. Answer. Correct answer. D. Explanation. Backing up root and each PDB separately ensures granular recovery capabilities and isolates PDB restores without affecting others. Root level backups include CDB metadata but not always full PDB data for point-in-time recoveries. Backing up on a PBS risks missing CD but level metadata needed for proper restore. Separate backups provide flexibility and meet Oracle recommended practices. Question 17. The primary reason for generating our reports is to analyze performance trends and identify bottlenecks over specific time windows. Which statement best describes how to maximize the usefulness of our reports in troubleshooting intermittent issues? A. Compare our reports from problem periods to baseline reports. B. Only review the TSUL statements section for long-running queries. C. Ignore system-level statistics and focus on wait events only. D. Use IR snapshots with minimum one-day interval to capture trends. Answer. Correct answer. C. Explanation. Comparing problem and baseline I reports is crucial for context. Focusing solely on TOSQL may miss systemic issues. System-level stats, such as CPU, memory, and EO usage, provide vital clues alongside wait events. Our snapshot intervals should be balanced, e.g. 1 hour, to capture detailed trends. A daily snapshots may miss transient problems. Question 18. In what ways can SOFIA proactively prevent tablespace space exhaustion in a heavily used database that frequently performs large batch inserts? A. Enable automatic segment space management (ASM) and monitor free extents regularly. B. Increase tablespace size only when space errors occur. C. Use manual segment space management to tightly control space. D. Defer monitoring to weekly checks by DBAS only. Answer. Correct answer. B. Explanation. ASM optimizes space allocation but must be complemented by proactive monitoring and timely space extension to prevent errors. Increasing table space only after errors causes downtime and failures. Manual space management is error-prone and inefficient for dynamic workloads. Weekly monitoring is insufficient for high-activity environments requiring near real-time insights. Question 19. Across different scenarios, Rog wants to audit select operations on a sensitive column only when accessed by unauthorized roles. Which Oracle feature best meets this requirement? A. Fine-grained auditing (FGA) policies with specific predicates. B. Standard database auditing for all select statements on the table. C. Trigger-based auditing on select operations. D. Privilege revocation to prevent access instead of auditing. Answer. Correct answer. A. Explanation. FGA allows precise auditing based on predicates and conditions, enabling selective monitoring of sensitive columns accessed under specific contexts. Standard auditing logs all selects indiscriminately, generating excessive data. Triggers cannot audit selects. Privilege revocation enforces security but does not provide audit trails needed for compliance. Question 20. With respect to minimizing risks before applying a major patch, Carlos wants to validate the patch impact on the workload by replaying production workloads in a test environment. Which Oracle feature should he use? A. SQL Performance Analyzer. B. Database replay feature of real application testing. C. SQL Tuning Advisor with capture mode. D. Atom report before and after patching. Answer. Correct answer. See explanation. The database replay feature in real application testing records and replays full workloads to simulate real production environments, providing comprehensive patch impact analysis. SUL Performance Analyzer evaluates individual SUL statements rather than full workloads. SUL Tuning Advisor does not support workload capture or replay. ADAM helps diagnose problems but cannot replay workloads. Question 21. In a context of managing multiple databases in a large enterprise, Ravi wants to ensure that backup metadata is stored centrally to enable recovery operations from different hosts without dependency on the target database. What is the best practice for Oraman catalog deployment? A. Create a single recovery catalog database shared by all target databases. B. Maintain a separate recovery catalog database for each target database. C. Use only the target database control file for backup metadata. D. Store recovery catalog metadata on a shared network file system. Answer. Correct answer. B. Explanation. Maintaining separate recovery catalogs for each target database provides better fault isolation, security, and reduces the risk of a single point of failure. Sharing a single catalog can cause contention and security risks. Control files store metadata locally but do not provide centralized recovery metadata. Shared network file systems are not suitable for Oraman catalog storage as they lack Oracle managed transactional integrity. Question 22. When considering disaster recovery strategies, Prayer configures a physical standby database to allow read-only queries without affecting recovery apply processes. Which Oracle feature enables this capability? A. Active Data Guard with real-time query enable. B. Logical standby database with query write. C. Snapshot standby database mode. D. Standard physical standby in read-only mode. Answer. Correct answer. D. Explanation. Standard physical standby databases can be opened in read-only mode but will suspend redo apply, affecting recovery timeliness. Active Data Guard allows real-time query access while continuously applying redo, providing better availability. Logical standby supports query and DML but has overhead in SQL apply. Snapshot standby is used for testing and suspends redo apply during read-write mode. Question 23. Based on the information, Ahmed mistakenly deleted rows from a critical table and wants to recover only the deleted rows without affecting other data or the whole database. Which feature should he use? A. Flashback table to a specified SEN or timestamp. B. Flashback database to the point before deletion. C. Restore the entire data file from backup. D. Perform an Oraman incomplete recovery. Answer. Correct answer. A. Explanation. Flashback table allows recovering a table to a previous point in time independently, preserving other data changes in the database. Flashback database reverts the entire database, causing more downtime and potential data loss. Restoring data files and incomplete recovery are time-consuming and affect larger scopes than necessary. Question 24. Given the circumstances, Samuel wants to tune the instance recovery time in his old database to reduce downtime after unexpected shutdowns. Which parameter is most critical to control recovery duration? A. Fast ITR target. B. EB cache size. C. SGA max size. D. Log archive dest. Answer. Correct answer. A. Explanation. Fast start ER target controls the target mean time to recover after instance failure by balancing recovery speed and checkpoint overhead. Cache sizes affect runtime performance but not recovery time. Log archive dest specifies archive log destinations unrelated to recovery duration. Question 25. Through the lens of performance optimization, Vanessa notices some queries degrade after database upgrades. Which tool helps her identify problematic SUL and recommends tuning actions including index creation or SUL profile generation? A. SQL Tuning Advisor. B. Automatic Workload Repository. C. SUL Access Advisor. D. Real Application Testing. Answer. Correct answer. C. Explanation. SUL Access Advisor focuses on physical design improvements like indexes and materialized views. SUL Tuning Advisor analyzes SUL statements and suggests profiles, rewrites, or statistics improvements. Automatic workload repository collects performance data but does not suggest tuning actions. Real application testing replays workloads for testing changes. Question 26. In what ways can Eagle repair a corrupted data block within a data file without restoring the entire data file or taking it offline? A. Use our man block media recovery to fix specific corrupted blocks. B. Restore the whole data file from backup. C. Use flashback table for block recovery. D. Drop and recreate the affected table space. Answer. Correct answer. A. Explanation. Our man block media recovery targets only corrupted blocks, minimizing downtime and avoiding full data file restore. Restoring entire data files is disruptive. Flashback table cannot repair physical corruption. Dropping table spaces is destructive and unnecessary. Question 27. Considering the evidence, Layla wants to monitor resource usage and performance statistics for individual PBS inside. A. Wish Dictionary View provides detailed PDEO and performance metrics. A. CDEO stats. B. vSession. C. EBA tables. D. vSkill plan. Answer. Correct answer. D. Explanation. CDB O stats provides PDEO stats essential for PDBit level monitoring. vSession shows session information but not aggregate EO metrics. EBA tables describes table metadata unrelated to performance stats. vSkill plan shows SQL execution plans helpful for query tuning but not overall EDB resource usage. Question 20. In light of recent developments, John must ensure backups stored offsite are encrypted to prevent unauthorized access without modifying application data. What is the recommended method? A. Euroman's transparent encryption with Oracle Wallet integration. B. Encrypt data at the application layer using column encryption. C. Use OR-level encryption on backup files. D. Compress backup files without encryption. Answer. Correct answer. B. Explanation. Our transparent encryption encrypts backups efficiently without application changes, ideal for compliance. Application-level column encryption secures specific data but does not protect backup files entirely. OR-level encryption can protect files but may complicate recovery and management. Compression alone does not provide security. Question 29. While examining database growth, Tina wants to prevent table space exhaustion during bulk data loads. What is the best approach? A. Enable auto-extend on table spaces with a maximum size limit. B. Monitor space weekly and manually add data files as needed. C. Use manual extent management to tightly control segment allocation. D. Limit the number of concurrent sessions performing inserts. Answer. Correct answer. A. Explanation. Auto-extend allows table spaces to grow dynamically, avoiding space errors during bulk operations. Manual space addition and extent management risk downtime and errors. Limiting sessions may reduce concurrency but does not solve space issues directly. Question 30. Given the circumstances, Omar wants to ensure data consistency and cache coherence across rack nodes while minimizing latency. Which mechanism achieves this? A. Oracle Cache Fusion via Global Cache Service. B. Shared redo log files on NFS storage. C. Separate undo table spaces on each node. D. Using local undo for read consistency. Answer. Correct answer. D. Explanation. Oracle Cache Fusion coordinates block transfers among instances to maintain data consistency, minimizing latency. Shared redo log files on NFS can cause performance issues. Separate undo table spaces per node are standard but don't ensure inter-node cache coherence. Local undo supports session-level read consistency but is insufficient for cluster-wide coherence.